We are at a critical point in solving the climate crisis. The next few years will be the most important in human history. If by the year 2030, humanity has not cut its greenhouse gas emissions, principally carbon dioxide, by 50%, we are on track to ruin ecosystems, bake the ocean food chain into oblivion, threaten the production of oxygen that we all breathe, descend drought onto the Amazon rainforest, cause flooding, wildfire, and to continue the current freshwater crisis on many people of the world that do not have the wealth of the Western nations. In 2015, the nations of the world gathered in Paris and signed the Paris Climate Accord. This was an agreement among every nation in the world to stop global warming at 2 degrees Celsius and to make very strong attempts to stop it at 1.5 degrees. This more aspirational target of 1.5 C was pushed by the developing world, including the atoll nations of the world, tropical nations, and those that have a lower level of development than principally the Western world. So these two targets, 1.5 and 2 degrees Celsius, represent the aspirations of humanity when it comes to weaning ourselves off of fossil fuels and the emission of carbon dioxide that traps heat in the atmosphere. Let's break this down, unpack this information, and look at how global warming works, what is involved in climate change, and what are the impacts of this phenomenon. The greenhouse effect is a natural process which traps heat in the atmosphere that is on Earth's surface, the lower levels of the atmosphere, that would otherwise escape to space. The way the greenhouse effect works actually keeps Earth's surface at a temperature that allows for life. Without a natural greenhouse effect, the average temperature on our surface would be below freezing. Sunlight arrives at Earth, travels through the atmosphere, and if it hits a bright surface, such as a snow-covered or glaciated surface, it will reflect back out. This reflected sunlight does no work in terms of influencing the atmosphere or the temperature or the climate. But if sunlight hits a body of water or a dark continent, which is really any continent, the dark surface will absorb that sunlight and then re-radiate it in the form of heat. This heat will be trapped by a set of gases known as greenhouse gases, principally carbon dioxide. The molecules of carbon dioxide will vibrate and re-radiate that heat in all directions, and importantly, some of it will be directed back to Earth's surface. So there's a second heating effect that takes place. The more carbon dioxide and other types of greenhouse gases that are in the atmosphere, the more heat is trapped. There is a phenomenon known as a feedback effect. It turns out that water vapor, H2O, is the most powerful greenhouse gas in nature. But the average lifetime of a water molecule in the air is a week or two. Everybody has studied the water cycle. However, by warming the air through some other greenhouse gas, such as carbon dioxide, that warmer air will hold more water vapor. We all know that when it's warmer outside, it also tends to be more humid. So warm the air with carbon dioxide. Let's say it warms 1 degree C above normal. The humidity or water vapor that is also put into the air will give you an additional 1 degree of temperature rise. This is called a positive feedback effect. The climate system has many positive feedback effects, some of which we understand, many of which we don't, which means going forward and adding more greenhouse gases to the atmosphere and triggering more changes in the natural system is likely to uncover some feedback effects that we didn't expect. The sources of greenhouse gas are in all activities of the human socio-economic system: agriculture, commercial and residential buildings, industrial activities and manufacturing, our transportation sector, not only cars and trucks and buses, but also the airline industry and the global shipping industry, and the generation of electricity. So let's look at the history of carbon dioxide buildup since 1880. That period of time is taken as the nominal beginning of the Industrial Revolution. The reason for this is because if we look at temperature measurements prior to the late 19th century, we're not confident that we can compare those temperature measurements with modern day temperature measurements. You can see that carbon dioxide accumulated in the atmosphere and by about the middle of the 20th century accelerated. This is the heat that was trapped by this buildup of carbon dioxide and other greenhouse gases. There is a lag of 10 to 30 years between the release of greenhouse gases and the heat that is trapped by them. This has important implications because it means if we were to stop greenhouse gas production today, we wouldn't know what the ultimate heating would be for a few decades. You can also see that this red line is very jagged. The points that are at the top represent anomalous warm years, and very often these are times when El Niño takes place. El Niño is simply a condition in the Pacific Ocean where the winds slow in the tropics, allowing a body of warm water near the Philippines, the western Pacific, to surge across the Pacific to the eastern side. In so doing, it releases heat to the atmosphere. This excess heat will cause a warm year and can lead to drought. It can lead to intense rainfalls and flooding. It can enhance wildfires and other reactions from the climate system. The negative points that are below in this trend represent La Niñas. These are times of very strong trade winds, which build up the West Pacific warm pool. They push warm water over to the area of the Philippines, and a lot of heat is buried in the Pacific Ocean that would otherwise be in the atmosphere, and that causes temporary cooling in the atmosphere, as well as some of these cool years are years of volcanic activity, which throw particles into the stratosphere, which is the next layer of atmosphere above the troposphere, which is where we live. Particles in the stratosphere can have a longer lifetime of many months, and they can reflect sunlight out before it comes down into the troposphere and interacts in the greenhouse cycle. We know that the rate of carbon dioxide accumulating in the atmosphere is accelerating. We know that the rate of warming in the atmosphere is also accelerating. Currently, the amount of warming is 1.1 degrees Celsius or 2 degrees Fahrenheit. This amount of warming may not strike you as being very significant, but imagine you have a fever of over 100 degrees. You don't feel well. If that fever persists for weeks, perhaps for months, your organs may begin to deteriorate. You can suffer brain damage. Even that little bit of temperature rise has a fundamentally important effect on an energetic system, a system that is based on energy. At the same time, we can walk in and out of shadows, under clouds, and exposed to the hot sun, and we'll feel temperature changes of tens of degrees. That's a very different phenomenon than permanently raising the temperature of a system. And it's Earth's ecosystem, ocean system. These systems are experiencing the equivalent of a low-grade persistent fever. Unfortunately, we're on track to turn this into a middle-grade and a high-grade fever, which can have severe consequences. The projections are that by 2030, we're looking at another half degree approximately of temperature rise, Celsius, 1.5 degrees C. So this target of the United Nations Paris Accord is already looking like it's going to be unachievable. And by 2045, we're on track to reach 2 degrees C, the other target of the Paris Accord. This is the data collected by NASA Goddard Institute for Space Science since the late 19th century. You can see that from year to year and place to place, there's high variability in the heating. But overall, over the more than 1 century of data represented here, there is a very strong net warming. We also see that the Arctic is warming twice as fast as the rest of the planet. This Arctic amplification is having a very important effect. It means the temperature difference between the tropics, which receive excess sunlight, and the Arctic, which does not receive enough sunlight. That temperature difference is reduced, and the gradient is reduced. That gradient drives airflow from the tropics towards the Arctic, and that airflow is reduced because the gradient is less. And what we're seeing is a general decline in atmospheric circulation around the world. This has important effects, which we will get into. You'll also notice at the top of the figure in the North Atlantic Ocean a blue spot. This is cold water. In fact, the first measurements of the temperature of the North Atlantic were taken by Ben Franklin when he was sailing back and forth to England and New England. We know that the temperature today in the North Atlantic is colder than any time since then. This cold water is the product of melting the glacier on Greenland. The Greenland ice sheet has been experiencing net decay or melting for several decades. That fresh water flows into the North Atlantic. We see it as a general cooling. And that cooling is also having an important effect by slowing down a marine circulation system. This circulation system, which consists of the Gulf Stream, many of you have heard of, carries heat out of the tropical region of the Atlantic Ocean up to the North Atlantic and releases that heat into the air, which keeps England and most of Northern Europe much warmer than it would be otherwise. Well, as we slow this circulation system with the fresh water from Greenland, we are not exporting heat from the tropics as rapidly. The sea surface temperature in the tropical region of the Atlantic is rising, and this means there's more fuel for tropical cyclones and hurricanes. One consequence of this is that we see hurricanes intensifying much faster than we've ever seen before, going from category 1 to category 4 or 5 within 24 to 48 hours. And the general slowdown in atmospheric circulation also means that the storms are moving slower. We saw a remarkable result of this with Hurricane Dorian in the summer of 2019. It moved over the Bahama Islands and came to a dead stop. The average wind speed exceeded 180 miles per hour with gusts of over 220 miles per hour. This is an average-sized tornado that sat on the Bahamas for 24 hours. The devastation, as we all know today, was absolutely incredible. With only 1.1 degrees C of global warming or 2 degrees Fahrenheit so far, we've already documented an amazing list of effects. Sea level rise is projected to have a 10% probability of reaching 6.5 feet or 2 meters by the end of the century. Antarctica is now melting 3 times faster than last decade. Greenland is melting twice as fast as it did last decade. The summer sea ice volume in the Arctic Ocean is absolutely collapsing real time. It's between 50 and 70% smaller than it was when we first measured it with satellites in 1979. We've observed a 12% increase in extreme rainfall around the planet, a 10% increase in the land area that's under drought. 66% of humans today face a water shortage for at least 1 month per year. There's a decrease in atmospheric circulation, as I said, and this means that the jet stream is slowing down. And I'll show you in a minute that a slower jet stream is unstable, developing large meanders, which can pull Arctic air down into regions that have never seen it before and pull tropical air up into regions that have never seen it before. This leads to billion-dollar crop disasters because of record-setting freezes and snow accumulation, and the drought leads to crop failure as well. We see wildfires, and we see stress on humans when we have drought conditions. There is a decrease in ocean circulation. The ocean is warmer. It is absorbing the excess CO2 we put into it, some of it, and this leads to a lower pH, ocean acidification. And the oceans have less dissolved oxygen, right? You know what gills are for on fish. That is to pull oxygen out of the water. We have a 2% decrease in dissolved oxygen in the world's oceans on average since 1950. The global wildlife population has decreased by 60% in recent decades. We are experiencing marine and terrestrial extinctions, and hurricanes are bigger, wetter, slower, and intensifying overnight. This graph shows the accumulation of carbon dioxide since 1850. You can see the dramatic increase. Now, this is also exemplifying the dramatic improvement in the health and welfare of humanity in the Western nations. By having a readily available, portable, and intense form of energy, as we do in oil, coal, and natural gas, we've been able to extend our lifetime. We have been able to improve our health. We've been able to improve the growing of food and have more stable sources of fresh water and food. So fossil fuels have been truly miraculous for humanity. The problem is a good thing can go too far. We should have been weaning ourselves off of fossil fuels when President Kennedy was first briefed on the phenomenon of climate change. And every president since then has been told and taught that climate change is eventually going to lead to dramatic episodes of extreme weather, affecting fresh water, food availability, extreme stress to the world's ecosystems. So we've known for a long time, and scientists have been telling the world for a long time, that global warming is going to continue leading to some dramatically negative effects. Unfortunately, the idea that fossil fuels would lead to these negative impacts from global warming was suppressed by the oil companies. They, in fact, engaged in a global campaign of deception. That, plus the fact that this is science and potentially difficult to understand for many people, and the difficulty of disrupting our lives, the inconvenience of moving to new sources of energy and perhaps reducing some of the comfort and availability of the riches and goods that we have in the developed world become used to, this has generally led to a reluctance of both the average population and the world's governments to take a dramatic turn into renewable energy that doesn't release fossil fuels. So now we are in a very difficult situation. In order to stop warming at 1.5 degrees C, we need to stop all greenhouse gas emissions by 2050. This means that every decade until then, we need to cut our emissions by 50%. Between 2020 and 2030, emissions need to go down 50%. Between 2030 and 2040, another 50, and between 2040 and 2050, another 50%, and likewise. This cut, when we have become so addicted to fossil fuels, is going to be extremely difficult. And as I'll show you, in fact, the projections are that humanity is going to go the other direction. In fact, we are currently projected to continue emitting more carbon dioxide. The situation's even worse. If we want the developing world, India, China, Southeast Asia, Africa, Latin America, if we want these billions of people to experience the same benefits from fossil fuels that the developed world has experienced, then the developed world, the European Union, the United States, Canada, these advanced nations need to cut their emissions even faster so that we essentially reach zero emissions in 1 decade by 2030. That will give the developing nations more time to use fossil fuels for building modern hospitals, modern school systems, highways, to secure their fresh water and food systems. This is called social equity, and it's an issue of fairness. We all need to keep that in mind as we come to appreciate the urgency with which we have to cut our fossil fuel emissions. Worse, the 50 largest oil companies are currently dumping 7 million barrels of oil on the world's market. This keeps the price of oil suppressed, making it more affordable. This reduces the assets of oil and coal that are in the ground. It pulls them out and it puts them on the market. Those are called stranded assets, and the companies are avoiding those stranded assets. And this basically keeps the junk feeding to the junkie. The stuff we're addicted to continues to flow, and it's cheap and easy to acquire. This is an amazing situation where the oil companies, who fully and publicly acknowledge that climate change is real, it's happening, and it's having negative impacts on humanity, nonetheless are continuing to push fossil fuels on the world's market. And at least one CEO of an oil company has said, yes, we understand this global problem, but we also have an obligation to our shareholders. This is putting profit before planet, profit before people. Let's talk about agriculture for a second. Agriculture is responsible for 31% of global greenhouse gas emissions. Since 1970, food crop production increased 300%, and half of all agricultural expansion came at the expense of forests. The food supply chain is responsible for about 26% of greenhouse gas emissions. Another 5% comes from non-food agricultural, such as biofuels and textiles. 43% of all ice and desert-free land on the planet is used for agricultural. 2/3 of all fresh water is used for food production. Synthetic pesticides and nutrients that come from agriculture activities and wash off into watersheds are responsible for 78% of global dead zones. These coastal dead zones number now in the upper hundreds. And deep plowing, a traditional form of industrial agriculture, opens up the soil to drying, and the carbon in the soil combines with oxygen in the air and produces CO2, so that soil becomes a carbon dioxide source, whereas, as we'll describe later, it should be a sink. It should help us take CO2 out of the atmosphere. Beef is responsible for 100 times more greenhouse gas production than plant-based food. Over 80% of farmland is used for livestock, but it produces just 18% of food calories and 37% of protein. Cattle and the grain they use require 1/3 of available land on this planet, 16% of all available fresh water. 1/3 of worldwide grain production goes to feed cattle to fatten them up quickly so that we can slaughter them by the time they reach 2 years old. We are deforesting the planet at the rate of 30 football fields per minute, largely to raise cattle and grow the grain that feed them. That was just the start. We're going to cover 6 different chapters as we move through this video. Chapter number 1, what causes natural climate change? As snow accumulates on Greenland and the continent of Antarctica, it gets buried by subsequent years of snowfall. It turns to ice, and trapped in that ice, which we can drill and sample through research activities, are little bubbles of air. These bubbles of air are samples of the ancient atmosphere. The atmosphere is so well mixed that by getting a sample of air from one location, such as Greenland or Antarctica, you can characterize the chemistry of the entire atmosphere on the planet. We take these ice samples, we put them in a vacuum chamber, we melt them, releasing the gas, and we can measure the content of the ice in terms of carbon dioxide and methane, and other gases, and in fact also dust. This jagged line is the history of carbon dioxide on planet Earth extending back 800,000 years ago. This may look like an irregular line that has no rhythm to it, but in fact, these low points in the line are ice ages. They are low amounts of carbon dioxide, which, because of the greenhouse effect, are causing cool periods known as ice ages, and these high points in the record are interglacials or warm periods, again, because carbon dioxide is high. We currently live in the latest interglacial called the Holocene. We'll look at that in just a minute. There is a regular rhythm to glacial cycles, and it is 100,000 years. And over the course of this record, we never see CO2 rise above a concentration of 280 parts per million. However, because of our use of fossil fuels in 1910 had resulted in increasing the amount of carbon dioxide to 300 parts per million. And by March of 2019, the concentration was up to 415 parts per million. The reason for this regular 100,000-year rhythm in natural climate is because of what are known as orbital parameters. Earth spins on a tilted axis. That tilted axis slowly tilts towards the sun and away from the sun, exposing the Arctic to more sunlight and less sunlight. This tip back and forth is called axial obliquity, and it occurs on a regular rhythm of 41,000 years. We also have Earth going around the sun in a more circular and less circular orbit. If the northern hemisphere happens to be in a summer configuration and it's close to the sun, we'll have a longer, warmer summer. But if it's further from the sun, we'll have a cooler, shorter summer. The tilt and the eccentricity combine with a phenomenon known as precession, which is that the axis draws a circle in the sky like a top that is running out of energy. Combine all 3 of these, and we can produce very short, cold summers where the snow does not melt from one winter to the next. And we are covering the planet with more and more ice and snow, reflecting more and more sunlight out. That drives us into an ice age. Combine these in a different way, and we can reduce the amount of snow and ice. We can expose more dark ocean and land. This will absorb sunlight and re-radiate the heat that is trapped by greenhouse gases. These regular comings and goings of climate have been in place for over 1 million years, and they are caused by the gravitational influence of other planets, the moon, and our orbit around the sun. The last ice age culminated roughly 20,000 years ago. And these orbital parameters maximized the long, warm summers that led us out of the last ice age into the current interglacial called the Holocene around 8,000 years ago. Since that time, the orbital parameters have been rearranging to send us down to the next ice age. And the globe has experienced a natural decrease in temperature of roughly 1 degree Celsius. We would expect to see the next ice age on the order of 50,000 years from now. However, that's not going to occur. Humans have now taken control of Earth's climate in what's known as anthropogenic warming, again, through the release of greenhouse gases from fossil fuel use. In fact, with the roughly 1 degree C of warming that's occurred so far, we see fundamental changes in important Earth systems. The West Antarctic ice sheet, which consists of several outlet glaciers that are flowing into the Southern Ocean, is now considered in a state of irreversible retreat. The Arctic sea ice, as we've seen, is shrinking in dramatic ways in the summertime. Mountain glaciers are melting all over the world and shrinking, and coral reefs are projected to experience annual bleaching before mid-century. We're on track to see 2 degrees C of warming in the next several decades. This is going to threaten the Amazon rainforest with drought. The great pine forests of the north, the boreal forests, are threatened with wildfire and drought, and they're already on the cusp of turning from carbon-absorbing ecosystems into carbon-releasing ecosystems. The oceanic conveyor belt, which begins in the North Atlantic, as we've discussed, is slowing down. El Nino events in the Pacific Ocean are projected to magnify, become stronger, and these super El Ninos are expected to occur more frequently. The Sahara Desert is expanding both to the north and to the south, and the Greenland ice sheet is likely to cross a threshold where melting will become unstoppable at some place between 1.5 degrees C and 2 degrees C. Again, we're on track to see that sort of temperature rise before mid-century. In fact, we are on track to see 3 degrees Celsius of warming, and in fact, 4 degrees Celsius of warming. We put into a vulnerable situation the East Antarctic ice sheet, which is a massive amount of ice, the permafrost of the world, which is holding huge amounts of methane and carbon dioxide, and it's threatened to be released to the air if they begin to melt, and the winter sea ice in the Arctic Ocean. If we lose the sea ice in the Arctic Ocean, that reflective component goes away, and that will cause a sudden jump in global warming as a feedback effect. The punchline is that humans are now in control of Earth's climate. Chapter 2, how does climate change cause an increase in extreme weather? Global weather disasters have tripled in the last 2 decades. In fact, as I mentioned, the circulation of air in the atmosphere has slowed. And as air moves from the tropics into the Arctic region, it turns to the right because of the spin of the Earth. That jet stream, which is normally a fast-flowing linear body of air, is starting to develop huge meanders. A large meander on the East Coast will pull Arctic air down to South Carolina, Georgia, and Florida. We'll see billion-dollar crop failures. And simultaneously, we'll see large meanders in the mid-continent and to the west, which pulls tropical air up into the mid-latitudes. This leads to promotion of wildfire, drought, and crop failure as well. In fact, this is a graph of billion-dollar weather disasters in the US since 1980. We can see this very strong uptick, and what's included here in the colored bars are winter storms, billion-dollar freezes, flooding, drought, wildfire, tropical cyclones and hurricanes, and severe rainstorms. Global extreme rainfall has increased, and at current emissions, greenhouse gas emissions, 70% of the world's population and GDP face a 500% increase in flooding impact. We're now seeing a phenomenon known as rain bombs. These are intense concentrations of precipitation that are so strong and focused that they can damage wood frame structures. Events like that overwhelm the drainage engineering that we have in our urban areas and lead to dramatic flooding. We're also dealing with rising heat. At 2 degrees C of temperature rise, large parts of the continent will exceed 104 degrees Fahrenheit every year. Parts of Asia, Australia, North Africa, South and North America will see this every summer. In fact, certain areas, such as India, are already experiencing temperatures of 110 to 120 degrees Fahrenheit in the summertime. Heat waves are the deadliest natural disaster in the US. They cause more fatalities than hurricanes, floods, tornadoes, and lightning strikes. And in fact, cities with 3 consecutive months where maximum temperatures exceed 95 degrees Fahrenheit are expected to increase by 800%. This map represents the cities of the world where we have 3 consecutive months of 95-degree Fahrenheit temperatures. You can see most of them are made up of small blue dots or slightly larger ones. These represent populations of between 100,000 individuals up to maybe 1 million or 5 million individuals. There's one megacity there, that large red dot of over 10 million individuals. Now let's see what this looks like by mid-century. You can see the number of cities with 10 million people or more. In fact, with 5 million or 1 million, increases dramatically. There is, in fact, an 800% increase in the urban population that experiences 3 consecutive months of 95-degree temperatures. Hurricanes are also experiencing dramatic changes. As the sea surface temperature increases, that provides more fuel for tropical cyclones, which then become hurricanes. They are larger with the increase in water vapor in the atmosphere. There is more rain. They cause much more flooding when they run aground. The winds are stronger. Higher category hurricanes are becoming much more common. We're seeing category 4 and 5 hurricanes every summer now, which they used to be a relative rarity. Hurricanes are traveling slower because circulation in the air is reduced. That means that when they come over an area, they dwell there longer, they cause much more damage. There's much higher storm surge, which is the flooding on the coastline associated with a hurricane. And importantly, they are shifting to new locations. Around the world, tropical cyclones are migrating away from the equator. For instance, this has dramatic potential in Hawaii, where I'm from, as hurricanes that used to pass to the south of the Hawaiian Islands migrate to higher latitudes. They're now on track to intersect the Hawaiian Islands much more frequently than we've seen in the past. Let's take a look at what a hurricane does when it runs over a coastal city. We're going to look at Hurricane Michael, which occurred in October of 2018. Hurricane Michael ran over the community of Mexico City Beach in the Florida Panhandle. Hurricane Michael caused massive devastation to this city. You see 2 types of houses or 2 types of responses to the hurricane. There are still standing buildings which were built with modern building codes, and there are completely destroyed buildings. These are piles of 2x4s and drywall. So building codes are the key to surviving the storm surge, the high wind, and the high rain that are associated with the hurricane landfalling. The average annual budget for Mexico City Beach, Florida is about $6 million. The cost of just cleaning up the debris was 10 times that, $60 million. There was, in addition, hundreds of millions of dollars of additional repairs that had to take place. This illustrates how communities on the coastline have to draw from state budgets and federal budgets in order to recover from a hurricane strike. The Western U.S. fire season is 150 days longer than 40 years ago. The number of large fires has tripled. We see global extreme weather events on the rise. We see floods increasing 15-fold, drought mortality 10-fold, wildfires 7-fold, and extreme temperature events 20-fold across the planet. In fact, Munich Re, the large reinsurance company, has released data on insured losses. You can see this dramatic increase in insured losses from meteorological events, hydrological events, and climatological events. A good portion of this is the result of the influence of climate change, leading to a higher probability of extreme weather and a greater frequency of extreme weather. As insured losses increase, the insurance companies are going to raise premiums, and that is going to cause a rise in the general cost of living for everybody in every country. 68% of extreme weather events map onto climate change. Extreme weather events are now studied by scientists, and we find that 68% of extreme weather events around the world have some component of climate change at their root. They are either more likely and or more severe. Heat waves constitute 43% of such events, drought 17%, and heavy rains and floods 16%. This is a map of 260 different events over 8 years, all studied and published and found to be made more likely and more severe due to climate change. Sea surface temperatures are rising. El Nino is a short-lived phenomenon that dramatically raises sea surface temperatures, and as I've mentioned, El Nino events are projected to be stronger and to occur more frequently. And we now have a phenomenon that's been identified by scientists called marine heat waves. This is a map of marine heat waves going back to 2003. In fact, we know that marine heat waves have increased 54% since 1925. Sea level rise has coastal communities around the world very worried. Sea level rise is driven by melting of ice. We see an accelerating melt of Antarctica. That dark red section is the West Antarctic ice sheet, which is in a state of irreversible retreat. Antarctica is now shedding an average of 125 billion tons of ice per year. Greenland is also in a state of accelerating melting. It stands a 66% chance of melting in an unstoppable fashion by the time it reaches 1.8 degrees C, which may only be a decade or two from now. The Greenland ice sheet has a high altitude plateau, which still collects snow over melting every year. But once that high altitude plateau begins to see net melting instead of net snow increase, you begin to lower the elevation, which increases the probability of more melting, causing more lowering, and that's a feedback cycle that is unstoppable. We also get significant sea level rise by thermal expansion of the ocean. As it absorbs heat, it expands upward, and this is responsible for roughly 1/3 of the amount of sea level rise we're seeing today. Sea level rise hits our communities in unique ways. One way is called storm drain backflow. We're already seeing in many coastal towns high tide salt water come up through the drain system that we've installed designed to take rainwater off the streets and out into the ocean. This storm drain backflow occurs at the highest tides of the year. It creates salt water that occurs as wet spots in front of the storm drains and may flow down the gutter. The thing that most people don't realize as they're walking past these is that it hasn't rained. This is salt water starting to make its way into our urban communities. We also know that in the low-lying coastal zone where we've built very many cities and towns, there is a water table under the ground that goes up and down with the tides in the ocean. As the ocean rises then, this water table will rise. At high tide, there will come a time in every coastal town where a wetland will form for an hour or two and then go away, and then form again and go away. These wetlands are the result of the water table reaching the ground surface, and this phenomenon is known as groundwater inundation. If we're at high tide and the water table is high, meaning there's no dry soil, and the storm drain system is backed up with salt water, meaning there's no place for rain to drain, and we get a heavy rain, which we're seeing more of because of warmer air, this leads to flash urban flooding. This may be a rain event that had not previously caused flooding, but because of the consequences of sea level rise, you see ponding taking place, you shut down traffic, and in many areas, the highest tides of the year occur late in the day, right when urban communities are starting their drive home at the end of a workday, and they come to a dead stop. This separates families. They cannot pick up their kids at the end of the day. Teachers can't go home until all the kids have been handed off. Very often, we get families with isolated members living at home, waiting for the caregivers to arrive and not seeing them for many, many hours. This can have medical, emotional impacts that are going to increase as sea level rise increases. Here in Hawaii, we have modeled how sea level rise will affect Waikiki and our urban core. We recognize 3 types of flooding. In blue, you're going to see salt water flowing over the coastline with sea level rise. In green, it will be the storm drains backflowing salt water, and in purple, it will be groundwater rising and flooding the land surface. This is a map of Waikiki and urban Honolulu at today's high tide. With 1 foot of sea level rise, we start to see ponding forming from groundwater. That's the purple area. At 2 feet of sea level rise, we see a mix of storm drain backflow as well as coastal marine flooding and groundwater flooding. You'll notice small pink dots. Those are individual storm drains that are now backed up with salt water and no longer functioning. And you'll start to see long red lines. These are sections of road where the water is 6 inches deep or more, and that constitutes an engineering threshold where small cars will often stall, bringing that section of road to a complete halt. Between 2 and 3 feet of sea level rise, we pass a sort of a tipping point We go from irritating, perhaps minor disruption related to high tide flooding to major flooding, bringing miles of roadway to a halt and causing flood damage onto extensive areas of the land surface. 3 feet of sea level rise has been projected as a very high probability of sea level rise by the end of the century. However, if melting of the ice sheets and thermal expansion of the oceans continues to accelerate in ways that we aren't currently able to predict, because the physics of melting the ice sheets are very poorly understood, we could see 3 feet of sea level rise arriving closer and closer to mid-century. 4 feet of sea level rise and 5 feet of sea level rise are also possibilities before the end of this century. We also know that large waves arrive at different times of the year. These are not waves associated with storms or hurricanes. These are just waves that arrive from the southern hemisphere in their wintertime and from the northern hemisphere in our wintertime. Here we've simulated the wave run-up or flooding in a community on the island of Oahu with 2 feet of sea level rise. Notice the threshold we cross when we go to 3 feet of sea level rise. Again, this dramatic increase in flooding associated with that change from 2 to 3 feet of sea level rise. Chapter 3, how does climate change threaten food and water security, and how does this lead to violent conflict? Pollution and overuse of freshwater supplies have already created a global water crisis. And by 2030, global water requirements will exceed sustainable water supplies by 40%. Freshwater withdrawals in continental areas are already exceeding internal sources. Most fresh water around the world comes from aquifers. It's pulled out for irrigation principally, but also for manufacturing and for individual use. In the continental United States, freshwater is being withdrawn from aquifers at 17% greater than nature can replenish it. In China, water is being withdrawn from the ground 22% more than nature can replenish. India, 52%. In North Africa and the Middle East, freshwater is being withdrawn from aquifers over 1,000% greater than is able to be replenished by nature. And by mid-century, with human population growth and the spread of drought, water demand is projected to grow by 55%. Something that many people are not aware of is that soy, wheat, rice, and maize, or corn, grown in an atmosphere of higher CO2, such as we already have established, is less nutritious. We see less protein, and it's being replaced by carbohydrates, so these cereals are becoming more sugary. We see less vitamin B complex, less zinc, there's less iron, and overall there's a decrease in nutrition. This decrease in nutrition is projected to put an additional 300 million people into a state of malnourishment. And we're looking at an additional 1.4 billion women and children experiencing an iron deficiency. Wheat is a good example. Global wheat today provides 20% of all human protein. The yield of the wheat crop every year is threatened by drought, flood, and higher CO2 levels in the air. By 2050, the demand for more wheat is expected to increase 60%, associated with 9 billion people on the planet. The actual yield, because of the threats related to climate change, is expected to decrease by 15%. This is a recipe for food shortages. The tropics are becoming increasingly unlivable. Food shortages, water shortages, extreme heat, these trigger a global scale refugee crisis. We've projected that when the heat reaches 95 degrees Fahrenheit with 90 degrees humidity, based on 700 heat waves that have occurred, we see that combination as a border for fatality. With that combination going outside and simply experiencing that heat, the human body can no longer offload energy through the skin to the air. The humidity plays the role of coating our skin with a thin blanket, which greatly impedes the loss of heat from our bodies to the atmosphere. This leads to an excess buildup of heat within our bodies, and that leads to heat disease of various types. Food and water shortages, unlivable outside air temperatures, these can lead to violent conflict. And violence and these shortages and the heat stress drive people from their homelands. Today, we see nearly 1% of all humanity involved in refugee status. That is, they have been pushed out of their homes because of either shortages or violence and are looking for new homelands. A good example of the effect of this is in Syria. In the early 2000s, there was a 1,000-year drought which caused the failure of farms across the countryside. Millions of individuals, farming families, retreated into Aleppo, Homs, and Damascus. They found in the urban area evidence of the corruption of President Bashar al-Assad. There was a lack of jobs, education opportunities, a lack of clean housing, sewage treatment, medical facilities, food and water security were all scarce. And the young men in this population revolted. They formed a rebel army, and a civil war broke out. At the same time, the United States was pushing al-Qaeda out of Iraq and Afghanistan. They found safe haven in the political turmoil of Syria. We had presidential forces, rebel forces, and al-Qaeda, all fighting each other at different times. Russia entered, and the United States was a player in the backdrop as well. It was out of this chaos that ISIS spun up. We saw 4 million people flee from Syria. They traveled 2 possible routes. One was to the north, across the Aegean Sea into Greece. The other was through North Africa and then across the Mediterranean Sea. In both cases, these refugees had to be taken in boats by smugglers. Most times, these boats were unseaworthy, they were overpacked with people, and these refugees were given fake life preservers. What you see here is likely a series of life preservers that actually provide no flotation. If you look closely at this scene, you can see people desperately bailing water, and you also see them looking towards the camera for help. The smugglers would take these boats out to the 3-mile limit, and then they'd pull the outboard motor, expecting that the Coast Guards from the Italian or French or Spanish nations would come and rescue these folks. All too often, however, these boats would flip or they would founder, and these refugees would be put in the water, and we would see dozens of them drown within an instant. This broke up families. The tragedy was unimaginable. Close family members who had been traveling together for weeks, sometimes months, suddenly were lost at sea. As these broken families made their way into the European Union, they represented the worst emotional experience that humans experience, grief. Working through grief and then trying to find new homelands in the European Union where borders are porous and visas are not required, millions of these refugees descended on Europe looking for asylum, looking for a new safe haven. At first, nations like Germany were especially generous. Germany took in 1.1 million refugees in a very efficient system, distributing them to towns and villages across the countryside, but they kept coming. And it wasn't long before in many of the nations of the EU, we saw a backlash, a violent backlash from local neighborhoods and cities who just were overwhelmed by the demand from refugees. In fact, Brexit has its roots in wanting to stop the flow of refugees from the EU across the English Channel into England. By withdrawing from the EU, they would have more control over their borders and be able to control the refugees flooding into England. A consequence of this was the rise of an authoritarian class of politicians. We saw populists, tribalists, and demagogues, essentially, that rose in popularity because they pointed to the refugees as the reason for voter discomfort, for the dissatisfaction of voters with regard to their personal lives. This, in fact, characterized the United States as well. We saw a presidential candidate who was eventually elected pointing to the refugee problem along the U.S. southern border as a major reason why Americans weren't earning more money in their salaries, found a scarcity of jobs, and other problems. Although very few of them got elected, we did see one of these demagogues get elected in Austria. Sebastian Kurz was elected at the age of 31. He campaigned on a platform of closing the borders, outlawing the wearing of the hijab, the Muslim clothing, and severely restricting the practice of Islam. We see the rise of authoritarian governments like haven't been witnessed since the 1930s. In fact, there's a new class of climate kings now. Not only are we electing these ultra-conservative politicians, but Very often, because of the impact of weather disasters, there is the suspension of democratic policies, democratic norms that are then not put back into place. The U.S. military recognizes this problem as a global security threat.
We built society on this assumption of climate stability, and that stability is changing. All these things we take for granted, they're not just givens anymore.
A just released report from the Pentagon, climate change and the challenges it's creating for the military.
The latest report says global warming is driving weather to new levels of extremes.
If 99% of my intelligence told me there's an ambush waiting for me, I don't get to say, yeah, but there's that 1% that says there's no ambush, so the hell with the other 99%.
As a member of the United States military and 30-plus years of service in uniform, climate change is what we call an accelerant to instability.
If you have an area that is already unstable and then has the additional challenge of water shortages or food shortages or a disaster that makes people move, then you can start seeing conflict situations.
Syria's deadly conflict, a full-blown civil war.
If we look around the world today, we can already see conflict and climate in play right under the headlines that we're reading.
The new study finds climate change exacerbated the worst drought ever in modern Syria as a consequence of human interference.
Fragile social systems just need one more shock to tip them over the edge into social breakdown, into war.
Failure to think about how climate change might impact our globally interconnected system is a failure of imagination.
The flip side of the climate threat is the energy and resilience opportunity.
As a soldier, we're always looking to have an edge on the future. We can pay now, pay later.
Let's take a look at how climate change affects the living systems of the world. The oceans are hotter, more acidic, and they have less dissolved oxygen. By mid-century, we expect to see over 98% of all coral reefs afflicted by annual bleaching. It's hard to imagine coral reef ecosystems surviving this level of stress. In fact, we see a new phenomenon called global bleaching events, which are recognized by satellites. There have been 4 of these events since the Super El Nino of 1998. Prior to that, this phenomenon didn't exist. One of the problems with corals that bleach is that by discharging human sewage from coastal cities into shallow coastal waters, even if it's treated sewage, we are feeding essentially plant food, nutrients to a class of invasive algae. And these invasive algae will, within a few days, begin to take over bleached coral as they are weakened and they are unable to successfully compete against the algae. We aid this process by overfishing our reefs and by further stressing coral reefs with the pollutants that come out of our watersheds and out of our coastal towns and cities. If we were able to restrict and remove the stress from human communities so that coral reefs could respond to the climate change threats of the oceans, they'd likely stand a much better chance of successfully adapting to the new conditions. In fact, we see the widespread invasion of new robust species that are immune to the temperature and pH conditions of the changing ocean. So what were once complex, highly diverse coral reef communities are now basically turning into a monocrop, a single species of invasive weeds. Once a coral reef dies and you're no longer experiencing the secretion of the mineral matter from the living polyps that form the solid substrate of a reef, these reefs can get pounded into fields of gravel by large waves, which in many areas of the world arrive every year. And so we're seeing a new phenomenon called reef collapse. This is a photo of a collapsed reef offshore of Maui. Permafrost ecosystems are collapsing. There is a phenomenon called thermokarst, which is the growth of lakes on the surface of these Arctic regions. The amount of thermokarst we're seeing is occurring 70 years sooner than models had projected. Our impact on the living world is dramatic. Today, we are deforesting the planet at 30 football fields per minute. The number of insect species has decreased by about 1/3. 60% of vertebrate animals, 83% of all mammals, and 50% of all plants have been wiped out of existence. The recovery of the natural world will take 5 to 7 million years once the human stress is removed. There are dangerous new hot zones already exceeding 2 degrees Celsius cropping up around the Earth, largely in the continental areas. We see widespread wildfire attacking the boreal forests, the pine forests of the north. In 2019, we saw 1 million people experience a blackout from the utility because wildfire threatened the infrastructure designed to deliver electricity. The US East Coast in the summer of 2019 experienced a dramatic heat wave. Out in the middle of the Pacific, a marine heat wave that surrounded Hawaii led to hundreds of record-setting temperatures in the summer of 2019. The Amazon experienced drought, deforestation, and fires, leading to the loss of over 2 million acres just in 2019. In Europe, the summer of 2019 experienced 3 heat waves. That's an unprecedented number of heat waves. In the nation of Kuwait, the temperature reached 130 degrees Fahrenheit. It's impossible to continue normal national economic activities, social, recreational activities in temperatures like this have to remain inside. It's not long before many of these Middle Eastern countries are going to fail altogether, and we're going to see just the heat alone leading to migration of people from these locations. In 2019, there was a mega fire in Siberia of 30 million acres. It was so large that no nation attempted to go and manage it and put it out, including Russia. The city of Chennai in India, consisting of 10 million people, drained all 4 of its reservoirs. That megacity ran out of water. The outflow of people was characterized by leaving behind those who could not fend for themselves, the ill, the super young, and the elderly who could not make the trip. Australia wildfire put 8 million people in a state of emergency, and we saw 2.7 million acres of land in the state of emergency in the suburbs of Sydney were on fire, with the central urban area threatened. We also see mass mortality of animals. In one day in 2015, 200,000 antelope in the nation of Kazakhstan collapsed due to blood poisoning related to the high heat. In 2014, we saw 45,000 flying foxes in Australia drop to the ground dead, again, in one day due to overheating. In 2018, hundreds of millions of starfish all along the US West Coast simply dissolved. They died over the course of a year and a half, and we're still not sure why this happened, but the mass mortality occurred at the same time that there was a severe heat wave taking place in the ocean. In 2016, we saw 8,000 Alaskan puffins and auklets starve to death because the fish they normally rely on had not materialized that season because of overheating in the water. And in 2019, 5,000 birds across 10 species dropped from the sky in one day around a lake due to heat exhaustion. Globally, the wildlife population has decreased 60% in recent decades. Of all mammals on Earth, 96% are cows and humans. Only 4% of mammals are wild. Of all birds, 70% are chickens and other types of industrial poultry. Only 30% of birds are wild, and they are quickly being extirpated by feral cats and also by the stresses related to climate change. Scientists are having to come up with new terms to describe these phenomena. A scientist's professional reputation is based on trust that is established by knowing that the results are being delivered without emotion, without personal bias. But now we see papers with titles such as Accelerated Modern Human-Induced Species Loss, the 6th Mass Extinction, Biological Annihilation. Has land use pushed terrestrial biodiversity beyond a planetary boundary, unable to recover? Approaching a state shift in Earth's biosphere. Marine defaunation, a new term describing the loss of animal life in the ocean. And climate-related local extinctions are already widespread among plant and animal species. This paper reported on local extinctions already occurring in hundreds of species. They studied 976 species and found 47% of them already no longer found in their natural habitat. This paper has 15,000 co-authors. They issued this as a warning to humanity. They said that humans have pushed Earth's ecosystems to their breaking point and are well on the way to ruining the planet. You may have noticed this art piece that I used to transition to different topics. This was a high school senior capstone project from Christiana Im in Putuho School on the island of Oahu, Hawaii. She's expressing here ecological grief, which is now a formal psychosis. Ecological grief is a process that has recognized to hit climate scientists first because they are the ones most deeply entrenched in studying the loss of the natural world and the rise of climate change impacts. But it spreads also to other people who are non-scientists who are informing themselves of the severe impacts of climate change. Are we solving the climate crisis? Similar to the beginning of our talk, we looked at a graph like this, historical carbon dioxide emissions from the beginning of the 20th century up to present day. If we are to stop warming at 1.5 degrees Celsius, beginning in the year 2020 and continuing every year after that, we have to decrease our emissions 5% per year or 50% per decade. We must reach zero emissions by mid-century, and we need to engage in negative emissions is the term scientists use, which is pulling carbon dioxide out of the atmosphere because the amount we have put in there already forbids us, bars us from seeing the warming stop at 1.5 and in fact 2.0 degrees Celsius. So stopping emissions and then pulling that greenhouse gas out of the atmosphere. This has to continue for centuries. The fact is that conventional approaches to mitigating climate change are not working. Progress is falling well short of the Paris Agreement targets, and even the Paris targets represent less than 1/3 of the emission reductions that are needed to hit the targets. Today, less than 1% of all humanity is in full compliance with the Paris targets. Fossil fuel use is accelerating faster than renewable energy. Solutions to this by sector, such as the transportation sector or the agriculture sector, are geographically and through time irregular and spotty. Solutions must simultaneously end carbon emissions, pull roughly 1 trillion tons of CO2 out of the atmosphere, and adapt to centuries of weather disasters that we have set in motion and cannot stop. Any one of these represents an expensive and radical change in our current socioeconomic practices. In fact, in 2018, global emissions of carbon dioxide rose 2.7%. And 2018 was the first time in nearly 20 years that growth in renewable power failed to increase over the previous year. The International Energy Agency issued in their 2018 outlook the following statements. Energy demand is set to grow by over 25% by 2040. Renewables make up only 2/3 of this new capacity. Oil consumption grows due to rising demand for plastics, trucking, aviation, and new forms of energy. Accompanying this, CO2 emissions continued to increase to mid-century. We saw the Resources for the Future Institute, which is a congressionally mandated institute in Washington, D.C., issue the following projections. On the current trend, global energy consumption will go 20 to 30% or more through 2040 and beyond, led largely by fossil fuels. And the global economy becomes more energy efficient, although carbon dioxide emissions continue to grow unless we see a shift in current trends. Renewable energy grows rapidly in the future, though it primarily adds to rather than replaces fossil fuels. Electric vehicles play an important role in the future of transportation, but their effect is to restrain the growth of rather than lead to a decline in global oil demand over the next 2 decades. In fact, we should reject the assumption that scaling up clean energy will automatically replace fossil fuels. Historically, new energy sources have added to older ones. Oil and gas didn't replace coal. They simply were added on top. We continue to use coal to this day in ever-growing amounts. The same is happening right now with clean energy. The U.S. Energy Information Administration has projected that global CO2 emissions will grow 0.6% per year up until mid-century, 2050. And under most scenarios, carbon dioxide emissions from the global energy system are on a path to far exceed international targets of the Paris Agreement. Projections by the International Energy Agency, BP Oil, the U.S. Energy Information Agency, ExxonMobil, Equinor, Shell Sky, and other global energy economists all indicate a rise in CO2 emissions towards mid-century. In fact, the market share between fossil fuels and renewable energy sources by mid-century is projected to be roughly the same as it is today. We are, in fact, on path to see 2 to 4 degrees Celsius of warming in the second half of this century. That level of warming has been described by scientists as creating a fundamentally ungovernable planet. What are the solutions? We know how to solve this crisis. We know current trends are taking us to increased CO2 emissions to mid-century. Nations have stated policies that would create a decrease in emissions and create them level to mid-century. But what we really need to do is see declining emissions towards mid-century. Achieving this can be broken up into numerous sectors. Increased efficiency or energy usage on the part of motors, buildings, devices, appliances, shipping, aviation, cars and trucks, and industrial machinery can play an important role in reducing our emissions. Renewable energy, of course, solar, wind, biofuels, hydro energy, and nuclear energy are well positioned to replace fossil fuels if we can get the movement going much stronger than it has been. And electric vehicles, sequestration, and changes in personal behavior finish out the changes that need to take place in order to meet the Paris targets. Batteries are falling in price. They're down 85% over the last decade and 30% just since 2017. Utilities around the world are embracing batteries and are going to fuel the growth in renewables. Polls across the United States suggest that clean energy is now popular across the country, even though the term climate action is not. And there are now more than 3 million clean energy jobs in America versus only 50,000 coal mining jobs. We see a global movement for climate change taking place, led by a 16-year-old Swedish teenager who made the decision not to go to school on Fridays because she saw no point in continuing to go to school while adults are failing to provide her with a safe and prosperous future. This Fridays for Future movement has spread across the country, and in 2019, we saw the first global protest of anything, but in this case, climate, involving tens of millions of students and adults across the world. We also see the rise of truly disruptive, nonviolent social movements. An organization called Extinction Rebellion, born in England but now spread around the world, is leading to disruptive activities that are driving political systems to declare a climate crisis, to recognize targets for decarbonization, and to replace all energy sources with renewable energy.
This is not a drill. My name is Greta Thunberg. We are living in the beginning of a mass extinction. Our climate is breaking down. Children like me are giving up their education to protest. But we can still fix this. You can still fix this. To survive, we need to stop burning fossil fuels. But this alone will not be enough. Lots of solutions are talked about. But what about a solution that is right in front of us? I'll let my friend George explain.
There is a magic machine that sucks carbon out of the air, costs very little, and builds itself. It's called a tree. A tree is an example of a natural climate solution. Mangroves, peat bogs, jungles, marshes, seabeds, kelp forests, swamps, coral reefs, they take carbon out of the air and lock it away. Nature is a tool we can use to repair our broken climate. These natural climate solutions could make a massive difference.
Pretty cool, right?
But only if we also leave fossil fuels in the ground.
Here's the crazy part. Right now, we are ignoring them. We spend 1,000 times more on global fossil fuel subsidies than on natural-based solutions.
Natural climate solutions get just 2% of all the money used on tackling climate breakdown.
This is your money. It is your taxes and your savings.
Even more crazy, right now when we need nature the most, we're destroying it faster than ever.
Up to 200 species are going extinct every single day.
Much of the Arctic ice is gone. Most of our wild animals have gone. Much of our soil has gone.
So what should we do?
What should you do?
It's simple. We need to protect, restore, and fund. Protect. Tropical forests are being cut down at the rate of 30 football pitches a minute.
Where nature is doing something vital, we must protect it.
Restore. Much of our planet has been damaged.
But nature can regenerate, and we can help ecosystems bounce back.
Fund.
We need to stop funding things that destroy nature and pay for things that help it.
It is that simple. Protect, restore, fund.
This can happen everywhere. Many people have already begun using natural climate solutions. We need to do it on a massive scale.
You can be part of this.
Vote for people who defend nature.
Share this video. Talk about this.
All around the world, there are amazing movements fighting for nature. Join them.
Everything counts. What you do counts.
A second very important activity is to conduct our agriculture farming differently. Engaging in regenerative farming, which is to prevent the bare soil from oxidizing and drying out in the atmosphere with cover crops, low crops that we plant that actually protect carbon in the soil and put more carbon back into it. This type of regenerative farming is already adopted by many of the industrial farmers around the world. If we can get it to spread to every agricultural location on the planet, it can sequester or pull carbon out of the atmosphere sufficient to nearly equal what we've put into it. Let's listen to this video by the Terraton Initiative.
What if I told you that the most promising technology we have to address climate change is growing on 3.6 billion acres across planet Earth?
The ability of agricultural soils to pull carbon dioxide out of the atmosphere and hold it in the soil is literally the most optimistic thing I know about with regard to climate change. Today's agricultural soils contain about 1% carbon. Prior to cultivation, those soils contained about 3% carbon. If we could take every cultivated acre on Earth, which is about 3.5 billion acres, and get them back from 1 to 3%, that would represent sequestering about 1 trillion tons of carbon dioxide pulled out of the atmosphere by plants and put back into the soil. Prior to the Industrial Revolution, the Earth's atmosphere had about 280 parts per million. The most recent reading on the current concentration in the atmosphere is about 415 parts per million. If you take that difference and multiply times the Earth's atmosphere, that means there's about 1 trillion tons of carbon dioxide in the atmosphere today that wasn't in the atmosphere prior to humans starting to burn coal and oil. 1 trillion tons carbon dioxide. It represents both the scale of the problem and the scale of the potential solution. The Terraton Initiative seeks to remove 1 trillion tons, or a teraton, of carbon dioxide out of the atmosphere and into agricultural soils. So, how do agricultural soils actually capture carbon dioxide gas from the atmosphere and store it in the soil? The answer, as you probably remember from 8th grade, is photosynthesis. They attract carbon dioxide out of the atmosphere, use sunlight combined with chlorophyll, and turn that into sugars. And many of those sugars then go through the roots and into the soil, where they feed other living things in the soil. And over time, those living things continue to increase, and we increase the carbon concentration in the soil. We know that we can do this because there are farmers who are doing it today. It includes using no-till practices, using cover crops, more crop rotation. But we believe that at a cost of about $15 to $20 a ton, we would provide significant incentives for farmers to change practices and begin to sequester carbon, and that would represent a much lower cost than the alternatives. There are many solutions we should be pursuing to reduce the effect of climate change and reverse it. But sequestering atmospheric carbon in agricultural soils represents the only solution I know of that is scalable, economical, and immediate. So what will it take to make this happen? It includes farmers being willing to experiment with new ways of growing, businesses and all of us as consumers being willing to pay for it, and in fact demanding that our food and products are produced this way. And it requires that innovators come up with new ways of sampling soil, measuring carbon, coming up with products that replace a lot of the chemicals and fertilizers that are used today. Success in the Terraton Initiative will require collaboration from within the agricultural industry and from outside of the industry. But it's completely within our hands. We're not waiting for a new technical breakthrough. We don't need advances that aren't here today. We just have to decide collectively that we're going to make it happen.
So climate change changes everything. Each of us needs to change our personal behavior. The most valuable and impactful step we can take is to eat a more plant-based diet. This will cut down the impact of animal agriculture on the deforestation problem and on using the precious fresh water of our planet. We need to talk about climate change to those that are in our daily sphere of influence. And be brave, step out. As you learn more about climate change, give talks, meet with people, step outside of your comfort zone and spread the word. Every day, there are regular feeds of climate news. Stay on top of the latest trends in the nations, the latest trends in extreme weather and the buildup of greenhouse gases. Being an informed person is a fundamental requirement for continuing to talk about climate change. Most importantly, vote for politicians that will repair the climate, that will emphasize protection of the natural world, and to build resilient communities that use sustainable practices. Joining collective community action that is nonviolent but that demands change from our government systems is potentially the key to resolving this problem. If this can spread around the world and have meaningful impact, new policies and changes in laws related to renewable energy versus fossil fuel energy can be the fundamental solution we need. Remember how we began? The next few years will be the most important in human history. This is a fact. We need to face up to the challenge because we love our children and our grandchildren more than we love ourselves.